the second intro, how to present the intro to computer hardware. So intro to software. Intro to study the first part, the basics of ICT. We study 5 topics. The first one is basic concepts of ICT we study today, and then we study how to represent data in computer. And the last 3 one we study the computer hardware, software, and network. In the second part, we study the C programming language. So we study we study how to something about the data types, variable, structure. We study how to program, how to solve a problem using C language. That is the second part. Okay, so about the course will be organized as blended learning. So in some weeks I will send you the materials in which I record the theory, and I will also send you some exercise so you can study at home yourself. So some weeks I will teach you directly, and some weeks we study yourself. I will send you the clip that we record, and also we send you the exercise or assignment you do yourself. That is blended learning. How about how to evaluate? There are that is progress. You have a quick term. And this final exam. Okay, here some exercise. Also your will be organized together with the exams of our institute. That is exam organized for the whole university. So in the exam, the question, the result, and the same for all class in host. So the final exam will consist of 2 parts. First one is also multiple choice question and some programming. Okay, some C exercise. C need to program. Okay. So this one will be maybe Okay. So this is how to evaluate. Okay, so I introduce you about the cost. Do you have any question? So do you have any question? Nguyễn Văn Hưng, do you have any question?
Yes, I'm here.
Do you have any question? No?
No.
Okay, so if you don't have any questions, so we'll go to the first lesson, that is basic concepts of ICT. Okay, so can you see my slides, Trịnh Trọng Hưng? Can you see my slides?
Yes, we can.
Okay, thank you. So we go to the first lessons of introduction to ICT. So the first lesson is just introduction and overviews of ICT. Actually, I will show you the basic concepts of information and information processing. Next, I will show you the basic concepts of ICT and very overviews of hardware, software, and network. Okay, first one, what is information and what is information processing? So I will study the definition of what is information, so what is data, what is knowledge, and how data is processed using information system. Okay, so information is an abstract concept that describes anything that gives human a better understanding, greater awareness about any subjects in social or in nature. Example, so I'm teaching, so I'm see over the window, so I see the sun is sun. So it is sunny today, right? So is it a news for you? So this is information. So it is sunny today. So it is information. So, but this evening, I talk to my, if I talk to my baby that today it is sunny, it was sunny. So it is not information, because information that must give us a better understanding, a greater awareness about things in social nature. It means it should be news. Okay, if you have any question, you can ask me. Đỗ Huy Vũ, do you have any question? Đỗ Huy Vũ?
No.
Okay, so if anyone have a question, you can turn on the micro and ask me. Otherwise, you should turn off your microphone. Okay. In other words, information is something that people can learn, can know about, or understand. Okay, so these numbers show an example of information. Of course, this number was counts on 28. Sorry, I think counts in last semester. It means counts in 2020. At that time, this is information, right? At that time, at the day that the number was counted, this is information. But now, this data is old and everybody know it, so this is not information. Example, this morning I read in the paper that today there are no new COVID in Hanoi. So this is information. Okay, so in summary, information is an abstract concept that describes anything, but that must give us a better understanding, a greater awareness, or something new about any subject in social or nature. If something is old, so everybody knows it, understand it, so it is not information. So the second concept, what is data? Data is a representation of information using physical signal. So example, I say, today it is hot. Okay, it is information. But how hot it is? How hot it is? So I can say, today it is 37 degrees Celsius. So 37 degrees Celsius, that is data. That is data. Okay. And also today today is the first lesson, and I see the list of students, and I also see your name, your face the first time, right? So your name, you also data, your face, you also data. A list of students, you also data. Okay. So in other words, data concept refers to the fact that something existing information or knowledge that is represented or coded in some form that's suitable for better usage or processing. Okay, so data may be coded by physical signal as temperature, as humidity, or by text, or by picture, figure, or some number. That is data. So the first question, we talk about information, we talk about data. So we know that information has meaning, but data may not. So I say, of course, information have meaning because it gives us a better understanding, a news, or awareness, so it have meaning. But data may not have meaning. For example, so when I went to a hospital, so I did some blood test, right? So the result is a paper that have some number. So that is data, right? But I cannot understand what is the meaning of the number. What is the meaning of that data? So that data, I mean the result of blood test, has not meaning with me. It only have meaning with doctor. So doctor can understand it, but I'm not. So in this case, data has not meaning. Okay. Data can be coded as symbols, numbers, characters, or physical signals such as voice, light, temperature, pressure, humidity, or wind. This table is an example of data. So this is the results of Premier League, footballs of England, right? So this is data. So you know that information must be news, but data may not. This is old one. This is old result, but this is data. So in this data, in this table, data is number and character and symbols, right? Example 26, 19, 27, this is numbers. So Leicester, Tottenham, character, or P or GD, that is symbol. Okay, that is example of data. So data is a physical representation of information. The first question. So information and data, which one appears in advance, or which one obtains from the other one? Okay, Tống Duy Anh, can you ask this question? Between information and data, which one appears in advance, or which one is obtained from the other one?
I think information is obtained from data.
Okay, thank you. But it's not the correct answer. Actually, data. Yeah, it is correct answer. So data appear in advance. So from data we obtain information. So the answer is information is obtained from data. So for example, I use an temperature metric. So I measure the temperature outside. The result is 37 degrees Celsius. So that is data. So from that data, we can conclude that today it is hot. So it is hot. Hot is information, and 37 degrees Celsius is data. So from data, we can retrieve information. So in another example, so I go to hospital. I did some blood test. So the result of blood test, that is data. So from that data, the doctor can conclude that if I have some disease or not. So if I have a disease or not, that is information. But the blood test result is data. So information is obtained from data. Data appears in advance. The third concept is knowledge. So what is knowledge? Knowledge is abstract level of information. Is abstract level of information. From information, we can analyze, can learn, can study. Is what? Knowledge. So knowledge is a familiarity, awareness, or understanding of someone or something, such as a fact, information, descriptions, or skills, which acquires through experience or education by perceiving, discovering, or learning. So from information, from the fact, from description, from skills, from something. So after have many experience or from education, we have knowledge. Okay, so example from data, that is 37 degrees Celsius, that is data. So we can conclude that it is hot. Okay, that is information. But for the adult, we know how hot is and what do we need if it is hot, right? We need to have a fan or have an air conditioning, right? But for a baby, 5-year-olds, right? He can hear, even he can read. He can read, it is not, but he don't know how hot it is. He don't know how to prepare a fan or an air conditioner because he don't have any knowledge about what is hot. Or another example, okay, from the blood test, that is data, the doctor can conclude that I have some disease, that is information. So even that, I know I have such a disease, but I don't know how to solve, how to avoid, or how to what medicine, what thing to do, because I don't have any knowledge about that disease. Doctor, they will tell me what need to do, right? Because they have knowledge about that disease. Okay, that is the difference between information and knowledge. Knowledge is obtained from studying or doing experiments. Okay. So the second question, information and knowledge, which one is obtained from the other one? So of course, knowledge is obtained from information. From information, after doing experience, after studying, after analyzing, we will have knowledge. So from data, after analyzing, we got information, and from information, after educating, we got knowledge. This is information system. In general, information system is a system that stores data, processes data to create valuable information or new data. So that is the definition of information system. Information system is a system that stores data, processes data to create valuable information or new data. And this figure shows the process of information system. Information system, information processing include 3 stages. The first, we need to input data, and then we process data, and finally we output data. All 3 stages, you need memory or storage to store data. So this is a model of information processing. We have 3 stages: input data, process data, and output data. All of it, we need storage to store data. We store input data, we store output data, and also we store data during processing. Actually, information can be processed manually or automatically using computer. The advantage of processing information using computers such as save time and save human resources. The second one is increase the correctness of processing, and the last one is automation. Of course, using computer to process information, there are also some disadvantages. So can someone tell me the disadvantage of processing information using human resources? Using computers. The disadvantage of processing information using computer. Can you tell me? Đinh Đức Anh.
Yes, I'm here.
Can you tell me some disadvantages of processing information using computer?
Yeah, in my opinion, here the people to processing information using the computer. First of all, they need a computer. Yeah, it's a vehicle.
Yes, yes, it's correct. The first you need a computer and some
maybe it's
equipment.
Yeah, the equipment.
Okay.
And they need to know how to work with it. Needs to be taught.
Yeah, yeah, it's correct. Actually, you need a program, right? A software.
Yes.
Yeah, it's correct.
Yeah, I think that's all.
Yeah, I think the last one, I think about the intelligence. Of course, we have AI. It means artificial intelligence of computer, but I think the difference between intelligence of computer and human. Example for some sensitive information, I think using computer maybe it's not as expect as using human, right? Okay, that are some disadvantages of processing information using computer. Okay, I have introduced you about three concepts in information, that is information, data, and knowledge. Next, I will show you some basic concepts of ICT, that is information technology, and information and communication technology. First, informatic concept is first used in 1957 by Steinbuch. It's a paper, Informatics, Automatic Information Processing. So it means at the beginning of the concept, informatic, that means automatic information processing. And it was defined in Germany by Steinbuch. But in England, the concept of informatic is not popular. And in England, they use the concept of computer science or computing science. That's the most popular today. At the beginning, the informatic means that is a science. So we know that informatic is a science that study methods, technologies, and techniques to process information automatically. So at the beginning, informatic means or focus on theory. They study how to process information automatically, more than the techniques, more than the technology. So at the beginning, informatics is very close to mathematics, but they study the method, the approach, the algorithm, how to process information automatically. And of course, the main equipment used in informatics as computers and communication devices. In the 20th century, informatics consists of two parts, or is split into two parts, hardware and software. Hardware study about the equipment, how to build, how to organize, how to produce equipment. And software study how to create, how to build a program, software, application, so that can run on equipment. So as that is the concept of informatics at the beginning. But nowadays, the concept of informatics is not popular because informatics is more about theory. And today, information technology is used in real life in industry, in social, in economic, is very, very popular and very usually, right? So nowadays, the concept of information technology, IT, is more popular. So what is IT? Information technology is the use of any computers, storage, networking, and other physical devices or infrastructure and process to create, to process, to store, to secure, and exchange all forms of electronic data. So the concept of IT is more about how to use computer and related devices in real life, right? Yeah, use computer, storage, networking, and other devices to process, to create, process, store, secure, and exchange data. So that is the difference between informatics and information technology. In other way, or in other words, information technology is the application of computers and telecommunications equipment to store, to retrieve, transmit, and manipulate data, and often in the context of business or as enterprise. That is the definition of information technology. So the concept of information technology is used usually in the ends of 20th century and the beginning of 21st century. But I think from 2005 or 2010 up to now, the concept of information and communications technology is more popular because in 20th century or at the beginning of 21st century, internet is very expensive and it's not popular. So normally we use computer separately, individually. But nowadays, internet become popular and cheaper, right? So most of equipment like computer, laptop, mobile, we use it over the network. So we add the word communication in IT. So we have information and communications technology, ICT. So this term consists of two parts. First is information technology, and the same we talked already, and then that is communication. So communication, it means we use IT together with network or internet. That is ICT. Okay, so in other words, ICT is more extensive term that stresses the roles of communications and integration of telecommunication. Computers as well as necessary enterprise software, middleware, storage, and audio-visual system, which enable the user to access, store, transmit, and manipulate information. So when we talk about ICT, we talk about also computer, it means information technology, and we talk also about the communication between computer. Okay, it means the network. The applications of ICT nowadays, so ICT is applied, is used in the most of aspects in our life, in business, in industrial, in economic, in science, in education, in whatever. So I think ICT is applied in all aspects of our life today, right? I don't know how to glow. I have to sell this Japan. Okay. And we know how to move this one. Okay, so we talk about the hardware, software, networks in ICT. Okay. Hardware. So computer hardware is the connection of physical parts of a computer system. So hardware include the parts inside the computer case, such as hard disk driver, motherboard, video card, and many other buses and cases. Computer hardware is what you can physically touch it, you can see it, you can touch it, you can bring it. That is computer hardware. So can someone give an example of computer hardware? Can someone give us some example of computer hardware? Hoàng Giao Linh, can you give some example of computer hardware?
Computer hardware, I think that is something such as hard disk, the drive, or the board of computer. Okay,
so very simple. So computer hardware example, monitor, right? Keyboard, mouse,
yes.
Speaker, right? Or some equipment inside the case, that is RAM, right? ROM, something inside the computer case. That is computer hardware. So hardware is things that you can physically touch, you can see it, you can bring it, you can touch it. Okay, that is hardware. Computer software. Computer software is also called a program or simply a software. Is any set of instructions that direct the computer to perform a specific task or operations. That is computer. So computer software is a set of instructions or a list of instructions. So we call it a program or simply a software. So it is used to direct or to control, to manage computer to perform a specific task or operation. That is computer software. Computer software consists of computer programs that the programmer created and libraries from programming language and printable non-executable data. So software consists of programs that programmer created, right? Library from programming language and data that builds software. Okay, so can someone give an example of computer software? Trịnh Trọng Hưng, can you give an example of computer software? Nguyễn Giang Nam, can you give an example of computer software? Nguyễn Tuấn Đức, can you give an example of computer software?
In my opinion, computer software, I think it is the file or folder of the computer.
So can you give an example?
It's like an app, right?
Yeah, apps. Example, Facebook is a software.
Yeah.
For example, Blue Zone is a software, right? Or
Yeah.
any games, any app, that is software. Okay. About the network, so I will talk about the history of network, so and how to classify, and talk about the basic component, and talk about the most popular application of network, that is internet. The first is definition. So computer network, or simply networks, is a group of computer systems. So that is a group of computer systems and other computing hardware devices. So computer network consists of computers and other devices, okay, that are linked together through communication channels to facilitate communication and sharing resources among the wide range of users. So when you talk about a computer network, there's three things that we should remember. The first is a group of computer systems and other devices. So example, in my home, I have some laptops and some desktop, and also I have a TV. Actually, I have two TV, and I also have some smartphone, and I have also a camera. So all are connected together. That builds a computer network. Okay, the first thing, the computer network consists of computer and other devices. Okay, that linked together. Okay, the second thing that we should remember is all devices are linked together using communication channels. If these devices is not connected together, they will not build a network. They build a network only if they are connected together. They can be connected together using Wi-Fi, okay, using Bluetooth, or using cable. That is communication channel. That is the second thing. The first thing, computer network is used for communicate information or sharing resources, sharing data. Okay, so we talk about computer network. We talk about sharing. The first, it is connected collection or group of computer and other devices. The second, that is connected together using some channel, and the third, that is used to communicate or share data, resources, or whatever. Okay. Example of computer network. Example, the network in our network in Tạ Quang Biểu library, or the network in a gaming room, or the internet, or the network in our home, as I told you. Next, I will show you the history of internet. Actually, the definition of internet was first created in 1950. And then in 1958, USA created the project, namely APA. So this project study how to connect computers in armies of USA, and in 1969, the first computer network was created in USA, and it is used for Army in USA. And then I think in 1990s, internet become popular, and around 1995 it was connected to Vietnam. And now I think there are around 5 billion users in the world that are using internet service. Okay, that is the history of internet. Internet is can be classified by in some way. So in if we functional to classify computer network, there are 3 types. The first one is client server. The second one is peer-to-peer, and the last one is multi-tier architecture. So a client server example, the computer network in our university. So there are some server that is installed in Tạ Quang Biểu library. Some server, some computer is used as a server. That computer store data, store program, and provide service, provide data, provide software for us computer. So that is server. And when you use your smartphone or use your laptop to connect to the server, to the website, a host, to see the result or to register for a course, it means your computer, your laptop, or your smartphone is a client, and that is client server model. So in client server model, there are one or some computer work as a server. They store data, store programs, store software, and they provide service to others. And the other computer, they access to server to use service, to see data, to run software. That is client. The second kind of computer network is peer-to-peer. So peer-to-peer, in a peer-to-peer network, all computer have the same role. No computer work as a server. All computer has same role. That is peer-to-peer. Example, a class. Okay, there are more than 100 students in a class, so you can connect together to create a network for working together or for running the same program, right? So all students is connect to the same network, but no one work as a server. All students have the same role. So that is peer-to-peer network. The last one, that is multi-tier architecture, is the combination of client server and peer-to-peer network. So this is the combination network that combines different kinds of network to the same network. That is multi-tier architecture. We can also use the range of use or the range of installation to classify the computer network. So we have, I think we have 3 main kinds. The first one is LAN. The first one is LAN. It is short for local area network. The second one is WAN. That is the second one is WAN. That is wide area network. And the last one is GAN. That is global area network. That is the 3 main kinds of computer network classified by the range of use. Okay, LAN, for example, the computer networks in our university, that is a LAN. Normally, a LAN is a network that consists of hundreds of computers and is installed in a company, in an organization, and in the areas that I think around less than thousands of meters. That is a LAN. That is okay. So example plan is computer in our university, a computer network in a company, in a game room. That is LAN. One, okay, one is wide array network. One is a network of computer that consists of thousands of computers and that is installed in a city. Example, the networks of Da Nang City. That is a one. Or the networks of Hanoi City. That is a one. And the last one is global array network. That is the network that is installed, that consists of all computer and that is installed over the world. That is GAN. That is three main. So we have three main kinds of networks. If we classify using range of use, that is LAN, the smallest one, a middle, and GAN, the biggest one. So we also have a PAN, personal array network. So example, the network that connects my laptop, my TV, my smartphone, my camera in my home. So that is PAN. Okay. And MAN, we also have MAN. MAN something just similar to one, but it's specifically for some organization or some company. So example, computer networks of police in Hanoi. So that is a MAN. That is MAN. About the range of use, I think MAN something similar to one about the range. Okay. We can also classify computer network by the network topology. We have bus network, ring network, grid network, and tree network. Bus network, it means we have a bus line and all network connected to that bus line. So this topo is very simple, but simple and cheap. But its reality is not as good as other network because it's very cheap and simple. So if the bus line is disconnected, so the network is fail. Right? Star network, on computer connect in a star topology. So it means each computer is connect to other computer in many lines, many ways. So if ignite is disconnect, each way is disconnect, the network is still work. Ring networks on computer are connected as a ring. It means there are two lines from each computer to the other one. So if one line is disconnect, the network is still work, but two lines is disconnect, the network fail. About grid and tree, so also each computer is connected to other computer through a node of line. It means if some lines is disconnected, so the network is still work. So depend on the topology, the cost and realities of network is different. The simple and cheap network, of course, is not good. The good network, of course, it is expensive and it's more reality. Okay. Okay, so we continue to talk about the components of a computer network. So to build a computer network, we need the following components. First, of course, we need a computer and other devices. You need a computer, and of course, you need a network card. Network card. The second, we need a communication channel to connect different computer to a network. And then we need network equipment, modem, hub, switch, gateway, router, bridge, and repeater. Modem. Okay. Modem is an equipment to connect your equipment with the internet provider. So modem is an equipment. It is able to connect your equipment, example computer, with internet provider. Okay, so example, you are subscribers of VNPT or Viettel Telecom. So Viettel Telecom or VNPT is internet provider, right? So you are subscriber. So you need a modem to connect you to provider as Viettel Telecom. So the aims of modem is to convert the signal from your equipment and send it to the provider, and then receive signal from provider and convert it, and then transfer to your equipment. So modem is installed in between provider of internet and the users of provider. Okay. Next is hub and switch. So hub is a networking device that allows one to connect to multiple PC. So example, our university host, we have only one or two channel from internet provider, and then we share this channel to all of user in our university. So in our university, there are more than thousands of teachers and staffs, and there are more than 30,000 of students, right? But we only have one or two channels from internet provider, and then we share, we split thousands of ports that can support each user in university. So that is the roles of hub and switch. So the hub and switch, there are many ports. That is the role. From one port we share, we split to it's a very old one. Okay, hub is very old one, and it's very stupid one. Switch is more intelligent. It's more intelligent one, but it has the same role. It's split from one port and share and divide into another port. Gateway. Gateway is an equipment that is used to connect between different computer network. Example, we have a different computer network. You need to connect together, so we will use a gateway or bridge. It's a gateway operator. Okay. Router. Okay. So example, I'm in Vietnam. I send an email or message to my friends in USA. So, okay, I can send message or whatever, right? But how can the message is transfer is sent to the correct address in that message, that data is sent from Vietnam through Singapore or Hong Kong, and then go to some gateway, some points in USA, and go to different gateway points in USA and sent to my friend in USA. So how can message, how can data, how can email is sent to the correct address? So we need a router. So a router is a networking device that forward data packets between computers, that forward. So at forward. So when I send an email or so when I type the address of emails of my it names of Facebook, it includes the address. So router will know that address and that will address in USA. That is the role of router. For it, the thing the same like gateway I talked already. Repeater. Okay, so when I send a message from Vietnam to USA, right? So the communication channel between Vietnam and USA is a optical cable that is installed under the sea, right? Under the sea, right? But because the length of the cable is very, very long, so the signal will reduce. The signal will reduce, and we need some equipment to repeat the signal. Repeat the signal. Okay, that is the role of repeater. So another example, in a big company, so we have one switch that is connected with a Wi-Fi transmitter, but the range of Wi-Fi is only around, I think, 30 or 50 meters, and we need something to repeat the signal, because the company maybe need to transmit data through hundreds of meters, so we need some repeater to repeat the signal. Okay, so okay, so to connect your computer or your equipment to the network, we need first computer, second communication channel, and third that is network equipment I talked to you already, and lastly we need a network software. Example, we need a web browser, right, to access to website, or we need network address translator, example in modem or in router, or we need firewall to secure our equipment, right? That is the network software. So there are 4 components that builds a network: computer or equipment, communication channel, network equipment, and network software. Okay. So the time's up, so we will have 10 minutes for break. We will come back at 2 and 10. Okay, so we have round, and we'll come back at 2 and 10. Okay, so we come back to the lesson. Okay, so can you hear me?
Yes, sir.
Okay, thank you. Okay, in the first lesson, I introduce you some basic concepts of ICT. So the first lesson is very simple and very short. So in this, in the rest time of the lesson today, I will show you the second topic, because this topic is very complicated and long. So we study the rest times today and next week. So the second topic is how to represent data in computer. Okay, so I need to share my screen. Okay, so okay, this topic is very important to understand how computer work and how we use computer, smartphone every day. So example, when you use your smartphone, so you make a picture, you create a picture, okay, and then you can open that picture. You can see, you can edit on screen, or you can upload to Facebook, or you can send to your friend. Okay, so how the picture is stored in your smartphone. Okay, so the picture show your face, your body, or show something that include the point, color, brightness, or something in smartphone. Okay, and you write some text and you upload in on Facebook. Okay, so how can smartphone understand the message? Of course, computer cannot understand character A, B, C, D, E, F, G. No, they cannot understand that. But how can the character is stored, is processed in your smartphone? So this lesson, I will show you how represent all data in computer. Okay. So we will study following topics. The first, we study about numeral system, because all data represented in computer using binary system. So we will study numeral system. And then in the second part, we talk about how to represent data in computer. First one, we study about the information unit. It is a very short one. And lastly, we talk in details how to represent integer, real number in computer, and also how to represent character in the computer. Okay. So I hope in the rest time today we will study the first one, numeral system. So what is a numeral system? A numeral system is a set of symbols and rules. So symbols and rules using which we can represent and determine the values of any numbers. That is a numeral system. So numeral system include symbols and rules using which we can represent and determine the values of any number. So each numeral system uses a finite set of symbols or characters or digits, and the number of that character, symbol, or digit is called the base or the radix of a numeral system. And because it is the base, then we denote it by B. Example, the numeral system we use every day, that is decimal system. So in the decimal system, we use 10 digits from 0, 1, 2, 3 until 9. So we use 10 digits from 0 until 9. Hence, the base of the decimal system is 10. Okay, so this is the system that we use every day. Mathematically, we can represent a number in any numeral system. You can define a system yourself. So you can define any system to represent or to determine a number. And in computer science, the 4 popular neural system are: the first one is decimal system, the second one is binary system, and then octal system and hexadecimal system. We talk about the decimal system because this system is used in real life every day, right? The second one, binary system, is a system that the computer can understand. So the computer can understand only binary system. The octal system and the hexadecimal system is used to because the binary system we use only 2 symbols, so the base equal to 2. So to represent a number, we need a lot of digits. So the octal system and the hexadecimal system have to reduce the number of digits in the binary system. So that is the reason that we use 4 numeral systems when studying computer science. Okay, so we will go to each one. The first one is decimal system. That is decimal system using 10 digits from 0 until 9, and hence the base B equal to 10. So in the decimal system, when we use n digits, we can represent 10 power n different values, ranging from 0 until 10 power n minus 1. For example, when we use 3 digits, we can represent 10 power 3 equal to 1000 different values from 0 until 999. So that is when we use 3 digits to represent numbers in the decimal system. In general, supposing that a number A, which is represented in the decimal system as the form of big A equal to small a with subindex n. So A subindex n minus 1. So until A subindex 0. That is the integer part of a system of a number in a decimal system. And also the fraction part, A subindex minus 1, A subindex minus 2 until A subindex minus m. That is the first part. So we know that for the integer part, we index from 0 until n, and index from right to the left. For the fraction part, we index from -1 until -m, and we index from left to the right. Okay. So if the number a is represented into the decimal system in this form, we can easily determine the value of a using this formula. So okay, so an we multiply with 10 power n. An minus 1 we multiply with 10 power minus 1. So until a0 we multiply with 10 power 0. So we know that 10 power 0 equal to 1. That is for integer part. For the floating part, a minus 1 we multiply with 10 power minus 1. And in summary, you have a formula. The values of a equal to the sums of ai 10 power I, in which I is the index of digits and I running from -m until n. So this is the general formula to determine the values of a number in the decimal system. So we know that because the decimal system, the base equal to 10. So here we use 10 power I, in which I is the index of the digits in the form. Okay, so example, the values of the number 5, 2, 4, 6. So we index. The index of 6 is 0, right? Index of 4 is 1. Index of 2 is 2, and index of 5 is 4. Is 3. Sorry, 0, 1, 2, 3. And hence the values of 5, 2, 4, 6 equal to 5 multiplied with 10 power 3, because the index of 5 is 3, plus 2 multiplied with 10 power 2 because 2 index 2, plus 4 multiplied with 10 power 1 because index of 4 is 1, and 6 multiplied with 10 power 0 because 6 index is 0. And of course it equal to 5,246. This is simple because we use it every day. The second example, that is it's a real number. So 254.6h, we use the same way, but we know that for the fraction part we index from -1. So index of 6 is -1 here. 6 multiplied with 10 power -1, and index of h is -2. So here h multiplied with 10 power 2. So this is the way to determine a real number in the decimal system. Okay, and in general, you can determine a values in a B-based system. Actually, we use the same way. We use the same way to index the digits, and we also use the same way to determine the value. But here we use the base b. In the decimal system, base equal to 10. We have 2 examples already, and in general, we use the base b here. Okay, we use the same formula to determine the values of a number in the B-based system. The same way to index, and the same formula to determine the value. Especially in the binary system, we use the base b equal to 2 in the binary system. Base equal to 2, and we use 2 digits consist of 0 and 1. So in the binary system, we use only two digits, 0 and 1. So we do that 0 and 1 is also called binary digits, or is also called the bit, and also called also the smallest information unit. So 0 and 1 is bit, is binary digit, and also the smallest information unit. That is two symbols, two digits is a binary system. Okay, similar to the decimal system, when we use n bits in the binary system, we can represent 2 power 10 because the base equal to 2. So you can represent 2 power 10 different values ranging from 0 until 2 power n minus 1. For example, when we use 2 bits, we can represent 2 power 2 equal to 4, right? Value. And those are 0, 0, 0, 1, 1, 0, and 1, 1. Okay. So another example. Okay. So I saw in the meeting chat. When we use n equal to 3 bits, right? We can represent two, right? Power 3 s number, right? And they are the first number is 0, 0, 0, right? Second one 0, 0, 1, 0, 1, 0, right? 0, 1, 1. That is the first 4 number. And the number 5, 1, 0, 0, right? 1, 0, 1, 1, 1, 0. And the last one, 1, 1, 1. So here is example. When we use 3 bits, we can represent 8 numbers. So here is 8 number when we use 2 digits. Okay. Okay. The question is how to determine the values of a number which is represented in a binary system. Given that we have the number A represented in the binary system is the same form. So big A equal to A, small a, subindex n. Small a subindex n minus 1 until index 0 for the into the part. Dot small a subindex minus 1 until minus m for the fraction part. So this is the representation of the number A in the binary system. The question is how to determine the values of A. Actually, we use the same formula, but here we replace the base equal to 2. We use the same formula, but we use the base equal to 2. Example. Given the number in the binary system 1101.001.1011. So the values of this one, how to determine the value of this one. First of all, we need to index the digits in the number. So this for the into the part we index from right to the left and from 0. So the first number here, bit 1, the index is 0, and bit 0 here, index 1, next 0 here, index 2, next one here, index 3, next 0 here, index 4, next one here, index 5, and the last one, index 6. So we have 2 power 6 plus 2 power 5. Of course, 0 multiple with 2 power 4 equal to 0, so we don't need to write here. Here, this number 1, index 3, so we have a 2 power 3, and 0, you don't need to write here, so we have a 1 multiple with 2 power 0 here, okay? For the fraction part, we index from right to the left and from 1, from minus 1, okay? So the first number 1 here, index minus 1, 0 here, index minus 2, index minus 3, and index minus 4. So we have plus 2 power minus 1, 2 power minus 3, and 2 power minus 4. And the values of this number in the binary system equal to 105.6875 in the decimal system. So we know that when we say we want to determine the values of a number in a system, it means we find the values of that number in the decimal system. Okay, we find the values of that number in the decimal system, and this formula in general is to find the values of the number n in the B-base system in the decimal system. Okay. So do you have any question?
I have, yes, sir.
Yes.
I have a question in meeting chat. Can you see?
Okay, so I think Carlson gives the correct answer to binary digits. So BI from binary and T from digits. Actually, this okay. Okay. Nguyễn Văn Ngọc. So it's not a big problem, right? I think the answer counter is okay. Binary digits, and I will check in slide. Okay, later on. Okay, thank you. Thank you, sir. Okay.
Thank you.
So this is the way how to determine a number represented in the binary system. Okay. Next, we will talk about how we do operation in the binary system. So it's a decimal system because we use it every day, so we don't need to study here. But in the binary system, there are some difference. First, we study how to do the plus and minus operation. So something different. Plus 1 plus 0 equal to 0 plus 1 and equal to 1. Okay. 0 plus 0 equal to 0, of course. And 1 plus 1 equal to 1, 0. We don't say equal to 10 because in binary system we don't have the 10 number, we have only 1, 0. Okay. Minus and 0 minus 0 equal to 0. 1 minus 0 equal to 1, and 0 minus 1 equal to 1, but we need to borrow 1 for the next minus. So we know that 1 plus 1 equal to 1, 0. 0 minus 1 equal to 1, and need to borrow 1. Okay, the first example, we plus 101 with 111. So we do as the same as in decimal system. We do digit by digit and from right to the left. Okay, here 1 plus 1 equal to 0, and we remember 1 because 1 plus 1 here equal to 1, 0. It means we write 0 and we remember 1 to the left, right? Okay, so 1 plus 1 equal to 0, and we remember 1 to the left. Okay, 0 plus 1 equal to 1, right? And 1 plus 1 with we remember from previous step. So 1 plus 1 equal to 0. We still remember 1 to the left, right? Okay, 1 plus 1 equal to 0. And also we remember 1 to the left. And 0 plus 1 with we remember from previous step equal to 1. And also we have a 1 we remember here. So the result is 1, 1, 0, 0. Okay. So is it simple? Is it simple? Come on, sir. Yes. Okay. Thank you. Okay. So I will take another example. Okay. So I will search something here. Okay. So I. Okay, example we plus 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, 1 here. Okay, and result. Okay, 1 plus 1, 1 plus 1 equal to. Can you see my screen? No.
No. No. Not yet.
Okay, sorry. Yes. Okay, so now can you see my screen?
Yes, sir.
Okay. We want to plus this one plus this number with this number. Okay. So we plus from right to the left. 1 plus 1 equal to 0, right? And we remember 1 here. So run. Okay. Okay. 1 plus 1 equal to 0, and we remember 1 here, right? 1 plus 0 equal to 1, and then 1 plus 1 equal to
0 and remember 1
here, right? Okay, so 1 plus 0 equal to 1, and 1 plus 1 equal to 0, and remember 1 here. 0 here, plus 1 equal to 1, and 1 plus 1 here again equal to 0, and 1 here, right? Okay, so the same here, 1 plus 0 equal to 1 plus 1 equal to 0, and remove 1 here, right? Okay, so 1 plus 1 equal to 0, but we remember 1 here, right? And 0, 1 plus 1 equal to 0, and remember 1 here, and 0 plus 1 equals to 1, right? And here 1 plus nothing equals to 1 here, right? So this is the reason. Okay, so do you understand?
Yes, sir.
Okay, thank you. Next, we study how to minus in a binary system. So again, we minus from right to the left. 0 plus 1, okay, equal to 1, but we need to borrow 1 here. 1 here, okay. 0 plus minus 1 equal to 1, and we also minus borrow 1 here, and 1 minus the number what we borrow in previous step equal to 0, and 0 plus 1 minus 1 equal to 0, and 0 minus 1 we borrow here equal to 1, and we also borrow 1 here, and 1 minus 1 equal to 0. So this is the result. Okay, so I will show another example. Example is minus here. Example. Okay. Can you see my screen? My word screen?
Yes.
Okay. Okay. 1 minus 1 equal to 0. 1 minus 0 equal to 1. Okay. 0 minus 1 equal to 1, right? And we need to borrow 1 here. Okay, so 0 minus 1 equal to 1, and we need to borrow 1 here. Okay. 1 minus 1 equal to 0, right? And 0 minus 1 equal to 1, and we need to borrow 1 here, right? 1 minus 1 here equal to 0 here. So here is the result. Okay. Understand?
Yes.
Okay. Okay, so now here example you minus this one.
So
Okay.
we actually remember -1, not 1.
Okay, you can understand that you borrow 1, it means you remember -1. Okay, but if you borrow 1, it means you need to minus 1 in the next step. Okay, so another example here we minus a smaller one for the big one, right? This one is smaller than this one, so it's smaller. We minus smaller one for bigger one. Okay, so it is 1 minus 1 equal to 0. 1 minus 0 equal to 1. This equal to 1. We borrow 1 here, right? So 1 minus 1 equal to 0, and minus 1 equal to 1. We borrow here, right? Okay. So now 1 minus 1 equal to 0, right? And 0 minus 1 equal to 1 here, right? So you need to borrow 1 here, right? Right?
Yes.
Because 1 minus 1 equal to 0. 0 minus 1 equals to 1, and you need to borrow 1 here. But now we don't have anything to minus this one, but we still borrow one, right? So we write this one. It means this should be a negative number because it minus smaller one for the bigger one. So we write here it should be a negative number. But in the binary system, the negative is represented differently from the decimal system. So we will study later then. Okay, but this is a negative number. Okay. Okay, so that is the way to. Okay, so I think time's up. Time's up. So we will see. So next week we study the octal and the hexadecimal system. Okay. So you can download slide. So here. Okay, I will upload to class material. Okay, you go to Teams, go to Files, and go to class materials. You can see the file. You can see the file, and you can download it. Okay, you can go to class materials and download the slides for the lesson today. Okay, so if you have any question, you can message to me. And also for the blended learning, because there are some weeks you will study yourself. I will send you the clip that we record, and I will also send you the exercise or assignment, and you study yourself. But I will inform in advance which one is the better. Okay. Okay. Okay, Nhật Minh. So next week I will show you some books. Of course, there are many Vietnamese books. Do you want Vietnamese or English, Nhật Minh? And Ngọc Huy. Okay, next week I will upload the full slides. Okay, so next week I will show you some. I will upload all slides of the course to the Teams.